Hello YouTube viewers, welcome back to my channel. I'm sreetips. Today what I'm doing is I'm going to demonstrate how to replenish the electrolyte in the electrolytic silver cell. As that cell operates, the electrolyte level, the actual level of the electrolyte will decrease due to evaporation. Plus, as the cell operates, some of the silver gets depleted out of the electrolyte. It gets plated out on the cathode as pure silver crystal. And if it's allowed to get depleted to real low levels, then we could start to see the copper plating out with the pure silver crystal and contaminate our pure silver crystal. So plus, I'm still trying to get used to using the new GoPro 8 camera here. So let's get right to it. This is my electrolytic silver cell. I added some impure silver shot here to the anode basket. And when I looked inside, I noticed that the electrolyte level has decreased due to evaporation. And some of the silver is exposed up along the edge there. And so also what happens in here as this thing operates is some of this silver in the electrolyte will plate out as pure silver crystal. So and deplete the electrolyte. So what we're going to do is we're going to dissolve a little bit more pure silver crystal and try to get in here and add some more electrolyte to replenish the level and replenish the concentration of the silver in the electrolyte. All right, I'm going to add a little bit of the silver crystal that I saved to a beaker here. Reset the scale to 0. It'll take about 100 grams or so, I guess. That should do it. 105 grams of pure silver crystal. All right, here's our pure silver crystal. What I'm going to do is add some distilled water to it. I filled that up to about the 200 milliliter level there. Now I'm going to pour in some nitric acid. For 100 grams of silver crystal, I'm going to add about, I'll start off with about 50 milliliters of concentrated nitric acid. Now we'll cover this up and dissolve it on medium-high heat. Just a shot of the electrolyte after it's been on the heat there for about 10 minutes. Okay, the time right now is about 20 minutes to 12, and what I'm going to do is most of the silver has dissolved. It's still got a little bit of reaction going on in there. What I'm going to do is mix up a little bit more dilute nitric here to get the rest of that silver to dissolve. All right, that's about 60 or 70 milliliters of distilled water. I'm going to add a little bit more nitric here. Carefully. That's about 20 milliliters or so of nitric there. Maybe 30. What we'll do now is add this 1:45, and if you look back there, the solution has completely dissolved. The silver has completely dissolved in there. So what I'm going to do is I've got another 20 grams of silver crystal here. Add that in to consume any excess nitric that might be in the solution. A little bit of excess nitric in the electrolyte is okay, but a whole bunch of excess nitric in the electrolyte is not good. Right, the time right now is about 2:15, and if you notice, the solution is boiling, but there's still fumes apparent inside the beaker. There's a little bit of silver crystal left on the bottom of the beaker. And so what I want to do here is I'm going to let this boil until all the fume production ceases, and I've still got just a little bit of silver crystal left on the bottom of the beaker. This will ensure that I've used up all the available free nitric acid in there. Time right now is 3 p.m. Just after 3 p.m. If you look in here, you'll see that all the silver's been dissolved except for that one little piece. There's still some fume production going on in there. So what I'm going to do is I've got a little bit more silver here in this beaker. What I'm going to do is add this little bit of silver to our electrolyte here and let it continue to boil until all the fume production goes away. Okay, I just added that silver, and if you notice in there, there must have been a lot of excess nitric because it's boiling up pretty good, and the fume production is picked up. So it's a good thing I added that extra silver. I overshot with the nitric additions. A little bit of excess nitric in the electrolyte is not a problem, but if we have a large amount of excess nitric, then any palladium that's up in the anode filter basket will tend to get dissolved by the excess nitric, and then it will pass through the filter and get down into our silver cell and contaminate the electrolyte in the silver cell. A little bit of palladium in the silver cell is not a problem either, as long as the concentrations are kept low. You can tell if you have palladium down in your electrolyte because it will turn the electrolyte green. But as you can see here, I have nothing but blue. However, up here in the anode basket, the impure silver shot that I added is very likely to have palladium in it. So if I had a whole bunch of excess nitric down here in the electrolyte, then what it would do, it would get into the filter basket here, dissolve out the palladium, and then the palladium would pass through the filter and contaminate the electrolyte in our silver cell. All right, the time right now is 4 p.m. and this is still cooking away. The silver hasn't completely dissolved yet, but there's fumes in there, so that tells me that we're still got nitric acid in there. The electrolyte level is down to about 200 milliliters. I have a little bit of still water here to rehydrate it. Let this continue to cook. mix everything up. And then we'll set it back on the heat and let this reaction continue. Time is 25 past 4. If you look inside our beaker here, no fuel production. There's a little bit of silver left down at the bottom down there. And with no fumes and a touch of silver left at the bottom of the beaker, it's safe to conclude that all the excess nitric has been used up in this reaction. So now we're going to take it down off the heat, let it cool down a little bit. We'll filter it and then add it to the silver cell. Got a number 3 slow flow filter in this funnel here. I'm going to dampen it with a little distilled water. Got to use distilled water here because we're dealing with silver nitrate. If we try to do this with tap water, the dissolved chlorides in the tap water would form silver chloride and ruin our electrolyte. So now I've got the filter paper in there, drawing a vacuum over there. We're going to pour the solution through our filter flask here. Still a little bit hot, not real boiling hot, but it's still a little hot. So here we go, we're going to filter our hot electrolyte here. Filtering operation here is just to remove any pieces of trash that might have made it in there. This pure silver crystal is going to be high purity, so it shouldn't have any junk in it, as you can see by the filter there. But stuff can fall down in there when you're doing the reaction, so we want to run it through the filter just to make sure we're nice and clear here. All right, here's our nice clean filtered electrolyte. What we'll do now is take this over to the silver cell over here. All right, let's see. The amperage is running between 0.7 and 0.8, and the level in there, as you can see, is a little low, so we want to try to get the level up over that silver crystal that's in the bowl there around the sides. This is about 5 days growth of crystal in here. So now I'm going to add the electrolyte. Just going to pour it right in carefully. And I'll rinse the flask into the beaker that we did the reaction in. Now what I'm going to do, if you look in there, you'll see that the silver is covered now by the electrolyte. So what we need to do now is stir it a little bit here, get everything incorporated. Okay, I've completed stirring it up. If you look in there, our level has been restored. The concentration of the electrolyte is been increased as well by adding the additional silver. The cell is back up and operating properly now. If you look here, the amperage is up to 1 amp. Current flow through the cell is directly proportional to the concentration of the electrolyte. This is the jeweler's waste. It's still in my shop. When I got other people's material in my shop, my hobby feels like a job. I'll be glad when this is over, but I'll be posting the video on this ordeal soon. I'm still trying to get used to using this new camera. And before I do that, I'll probably go ahead and post a video on this. This is about 1.5 ounces of pure gold that I refined from some carrot scrap. I'll probably run it through a couple more cycles using oxalic acid to polish it up. And then we'll melt this up into some small bars, 4 and 5 gram bars, offer them for sale on my eBay store. As you can see, making the electrolyte for the silver cell is not a quick and easy process. I do this about halfway through a batch of silver to replenish the electrolyte, both the level and the concentration of silver in the electrolyte. Palladium is soluble in just nitric acid, the only one of the 6 sister metals in a platinum group that is. For that reason, the palladium will tend to follow the silver, and if it's allowed to build up, it could contaminate the electrolyte in our silver cell. Also, if the nitric concentration is high in the electrolyte, then that excess nitric in the electrolyte in the operating cell will tend to dissolve any palladium that we capture in the filter up there and allow it to pass through the filter down into our silver cell and contaminate it. A little bit is not a problem, but if the concentration is allowed to get high, it could begin to plate out with the pure silver crystal and contaminate it. The main problem there is palladium's worth about 100 times more than silver. Just a couple other quick items here. I've got some stuff wrote down. I'd like to say thank you to the folks that have contributed to my PayPal account. Thank you very much. Those donations are much appreciated, and they go a long way towards helping me continue to make these videos. Let's see, comments. The comment section of these videos, I read those, and I read every one of them, and I try to answer questions as they come up, but I also benefit from the suggestions that people make in the comments section. So please feel free. Critical comments are just fine. I take criticism well, and often I learn new things from critical comments. Okay, I want to put a shout out. We're doing a collaboration with Tomoko's Enterprise, TOMOKO' Enterprise. And what that is, that's Dean. He operates that channel. He is experienced in doing sand casting. I have no experience with it. So what we've done is we've sent him some silver and a chess piece, and he's gonna show us how to cast that chess piece, and then I'll watch that video so I can learn how to do it myself and make a complete chess set out of my pure silver crystal. And last but not least, the new GoPro camera that I have here supports live streaming. So sometime in the near future, sreetips will have his first on-air live streaming video where you can ask me questions directly, streaming live. And that'll be coming up very soon. I'll announce the time in a future video. So, okay, that will conclude the video. Thanks for watching.